Hello again, everyone, and welcome back to Learn Linux TV. In this video, what I'm going to do is show you how to mount file systems from systemd using systemd units. And systemd gives us some extended functionality. Sure, it's not the only way that we can mount file systems in Linux, but it is a very good way. As you'll see in this video, it gives us additional features, additional options. It's going to be a ton of fun. What I'm going to do first is show you how to mount secondary storage with systemd, and then toward the end of the video, I'm going to show you how to mount an NFS share as well. And as an added bonus, what I'm also going to do is introduce automount units, which helps us mount file systems on demand. So what I'm going to do is just start the tutorial right here. I'm excited to dive in, so let's do that right now. Before we continue, I want to go over a few things regarding systemd. We're not going to go into too much detail about it in this video since I've covered this topic already in other videos. However, since we're going to be using systemd to mount file systems in this video, I think it makes sense to at least give you a refresher. Whenever you work with systemd, most of the time you are working with services. A service is a program that runs in the background. You can have it run all the time, on demand, or even leave a service disabled until you need it in the future. For instance, let's consider OpenSSH. OpenSSH runs in the background and gives you remote access to your Linux installations. It's one of many services that you might control via systemd, but it doesn't really matter what the service is in particular, since systemd services are managed the same way regardless of what the actual application is. And you don't have to follow along with this part of the video since it's just a refresher. Anyway, what I'll do is show you a few examples of systemd, and then later we'll see how everything ties into mounting file systems. Since I just mentioned SSH, I'll use that as an example. And one example is checking the status of a service like SSH. We could do that in systemd by running systemctl, status, and then the name of the unit. This is a Debian system. The name of the SSH service can vary from one distribution to another, but on this one, it's just simply SSH. Anyway, with systemctl status, we can check the status of a service. For example, we could see whether or not it's running. This one is. We could see whether or not it's enabled. We also see the vendor preset. Now, active running is pretty self-explanatory. That means that particular service is running right now. Enabled means that it's going to start it at boot. So every time you start your Linux installation with a service enabled, it'll start that service for you. The vendor preset, which is enabled right here, just pertains to the default. When you install a new service within a Linux distribution, it's going to use the vendor preset to determine whether it should be automatically enabled when you install it, or if it wants you to do that yourself. But anyway, the takeaway here is that we're checking the status of a service within systemd. And also, like I mentioned earlier, I have other videos on the channel that cover systemd in more detail. So I'll leave a card for such a video right here if you want to learn more about systemd. But anyway, let's move on to other examples. Now, like I mentioned earlier, if a service in systemd is enabled, it starts at boot time. If you want to enable or disable a service, all you have to do is run sudo, because we'll be making changes to the system. We'll run systemctl, and then to enable a service, we type the keyword enable, followed by the name of the service. Now in my case, SSH is already enabled, so there's really no point in doing this. So what I'll do instead is just disable it to show you the difference. So I'll press enter, I'll type in my super secret password, and then next what we'll do is check the status once again. We don't need sudo for that. Since we're simply just checking the status, we're not making changes. But anyway, I'll press enter here, and we can see the difference right away. It's disabled. Now it's still running. Disabling a service doesn't stop it from running. It just means that it won't automatically start the service when I reboot this particular computer. Now obviously the opposite of disable is enable. So I'll run that command right there to return SSH back to its enabled state. And as you can see, it flipped back to enabled. In addition to that, I can also stop a service. I'll just change the keyword to stop. I'm going to stop the SSH service. And now you can see it's inactive and dead. And one of the reasons why I'm showing you all of this in a video that's about mounting file systems is because all of these commands are commands that we'll also use later in the video when we go to mount file systems. So it's a good idea to have a refresher when it comes to how the basic systemctl commands work. So that way we can see how they differ when we're mounting file systems. Anyway, I'll just go ahead and start SSH. And now we can see that it's active and running. Anyway, like I mentioned, I'm not going to go into too much detail about systemd in this video, but the only other thing I want to make sure you're aware of is the concept of a systemd unit. And this confuses people, so I wanted to make sure to explain this, that way you'll understand it. A unit in systemd is any object that systemd can manage. So far in this video, we've been working with services, and that's a type of systemd unit. Most of the time when you work with systemd, you'll be working with services. And this is why I think some people confuse the terms unit and service when it comes to systemd, thinking they mean the same thing, but that's not really the case. A service in systemd is just one type of unit that systemd can control. However, there are other types of units in systemd, one of them being mounts. Mount units enable us to manage attached file systems. So basically, when it comes to systemd, a service is a type of unit, and a mount is another type of unit. For the remainder of the video, we're going to be working with mounts, since that's the main topic of this tutorial. So what I'll do is explain how to set up a mount, and then how to control it with systemd. After that, I'll throw in another type of unit later in the video, known as an automount unit. But don't worry, as usual, I'm going to break it down for you so that way you'll understand it better. What you're seeing here is a Debian VM I created specifically for this tutorial. Now the distribution really doesn't matter much for this particular tutorial, since the commands I'm going to give you should work fine with other distributions as well, assuming they use systemd, but most do. Anyway, in this case, I have another storage volume that's attached to this particular VM. So if I run lsblk, what you'll see at the bottom is SDB. It's a 32 gig volume, and it's not been formatted. We see that SDA, the main hard drive for this particular VM, has 3 partitions, SDA1, SDA2, SDA5. Now SDB has no partitions at all because I just created this disk. I've never formatted it or set up any partitions, so it's completely blank. As an aside, you don't have to work with VMs to follow through with this particular tutorial. Even if you have a physical PC and you attach a physical hard disk, another physical hard disk inside the computer, then you'll be able to follow along because the process is exactly the same. But the first thing we want to do is run lsblk because we need to know what our device names are. We definitely don't want to format SDA in this case because that's the main hard drive for this VM. If I do that, then it's going to stop working. So in this case, I know that SDB is the hard drive that I want to work with, so I'm going to focus on that. On your end, of course, these names might change. You might have yours as SDB, like I have, or SDC, or some other name. But you need to know what the name is, so that way we know which hard disk we're working with. Now, at this point in the tutorial, the commands that I'm going to give you to set up a secondary disk are not specific to systemd. We need to prepare the disk. That's always the case. Regardless of how we're mounting the disk, we always need to prepare it first. So again, the commands that I'm going to give you right now in this section are not specific to systemd. However, I will let you know when we get to the systemd specific steps later in the video. Anyway, we see that my disk, the disk that I want to work with, my secondary disk, is SDB, so we're going to work with that one. And the first thing we need to do is set up one or more partitions on the disk we plan on using. Of course, you could create additional partitions, but I'm going to keep it simple and have just one partition on this particular drive. So what I'm going to do is run sudo fdisk and then /dev/sdb. And again, remember you're targeting the proper device. You'll type /dev and then / and then the name of the disk that you found from the lsblk command a few moments ago. I'll press enter, and now we are in the fdisk console. If we type P and then press enter, it's going to give us our current partition layout, and in this case, like I mentioned earlier, I don't have any. So I'll clear the screen. Anyway, I'll type N for new. I want to create a new partition. I'm going to accept the defaults for everything here, just keeping it simple. So I'll press enter for a primary partition. Partition number, I just want one partition anyway, so I'll leave it at 1. For the first sector, I'll leave that at its default of 32 in my case. And these numbers will vary obviously, but I'm going to press enter to select the default for last sector. And now if I type P and press enter, we'll see that I have /dev/sdb1. Now before anyone mentions this, yes, there are other tools that you can use in Linux to create partitions on a hard drive. However, in my case, I'm just used to using fdisk. It's a bit old school, but it still works just fine. There's nothing wrong with it. But anyway, right here, it tells us that we have partition SDB1, but that's not completely true. Yes, it's kind of true. It's going to create that partition, but it's just telling us right now what it plans on doing. We haven't actually finalized any changes yet. So to finalize changes, what I'll do is press W for write and then press enter. Once you do that, it'll save the partition table and it'll also drop you out of fdisk. Now if I run lsblk again, we'll see that now we have partition SDB1 here on this particular instance. So far so good. Anyway, the next step here is we need to format the partition that we've just created. So I'll type sudo mkfs.ext4. Of course, you could use a different file system if you want to, but I'm going to keep it simple. Extended4 is a good file system anyway. And what we want to do is target the partition that we just created, in my case, /dev/sdb1. Just make sure that you're targeting the correct file system because if you format the wrong one, you could lose data. So just be careful. Anyway, I'll press enter. And that was really fast. The partition has not only been created, it's also been formatted. Now that we've created and formatted the file system, the next thing we need to know is the block ID for that file system. And to find that out, what we could do is type sudo blkid, short for block ID, and then /dev, then /sdb1, or whatever yours happen to be named. We'll press enter. And this gives us our universally unique identifier for that particular volume. And this is how that volume is identified on the system. And this ID follows the volume. The reason why we're going to be using this naming format is because sometimes the order of hard drives on a system can change. For example, maybe you rebuild your computer and you don't have your volumes plugged into the same SATA interfaces, so they can shuffle around a bit. But since this ID will follow the file system, that really doesn't matter. So we're going to use this. So what I recommend that you do is run this command, sudo blkid /dev/ whatever your name was for that particular volume. And then here in the double quotes, we have our UUID. So what you'll do is just copy that and then just save it in a text file somewhere. We'll be needing it later. Now the next thing we need to do is decide where we want to mount the file system. This can be just about any directory within your Linux installation, but a good default to use is the /mnt directory. In my case, what I've decided to do is mount mine at /mnt, and then I'll just call it disk2, just like that. Now, if you've created file systems and mounted them before, you're probably used to creating this directory before you mount the file system, because obviously you can't mount a file system to a directory that doesn't exist. But surprisingly, in this case, we don't need to create it. All we need to do is just know where we want it to be mounted. We'll take care of this later. Actually, systemd will take care of this for us. It'll create this directory for us. So we just need to know where we want to mount the file system, and you can write that down. That's really all we need to know at this point. And now this is the part where we get to the systemd specific commands and things that I'm going to show you in this video, because now we need to mount the file system, but we want to do it with systemd. How exactly do we do that? Well, let's get started and I'll show you. And the first thing that is really important to know when it comes to creating mounts within systemd is that the name of the file that we're going to create is very important. We're going to be creating a unit file, and well, the name is important, so we need to know what to name it. But thankfully, systemd can tell us what to name it. So what we could do is type systemd -escape -p --suffix. We'll set it equal to mount. We want to know what to name a mount unit. And then in double quotes, we're going to type the directory that we plan on mounting the file system to. In my case, like I mentioned, I want to mount mine at /mnt /disk_2. So I'll press enter, and it gives us a file name right here. So what I'm going to do is copy this, and then what we're going to do is create that file. So I'll type sudo nano. You could use another text editor if you want to, but nano works just fine. We'll type /etc, and then systemd/system. And then what we'll do is paste in that file name, basically the one that systemd gave us from the earlier command. So this is the entire path, /etc/systemd/system/mnt-disk_2.mount in my case. Just make sure you update that with whatever your file name happens to be. I'll press enter. And here we have a blank file. And here what I've done, I've pasted in the contents that should go into this file. Of course, you'll need to update this to match yours. Most of this is fairly self-explanatory. For example, underneath the unit stanza, we have description equals. We could type whatever we want for the description there. In the mount stanza, we have what equals. And this is noteworthy because we have /dev/disk/by-uuid / and then a bunch of random characters. Now earlier I had you run the blkid command against the volume that we've just created, and that returned our universally unique identifier. And that's what you see right here. So basically all you do is type /dev/disk/by-uuid and then / and then the UUID. Just make sure that matches the output that you got from that particular command and you should be good to go. In the line underneath that, we have where equals, and that's the directory where we want to mount that volume to. Now you might have chose a different name for yours. Whatever you decided to call your particular mount directory, you could just make sure that it's referenced there. In my case, I have /mnt/disk_2. Underneath that, I have type equals ext4. And that's just the file system type for that particular volume. If you decided to go with something other than ext4, be sure to update that. Next, we have options equal rw. We also have no A time there as well. So that's just setting read and write capability and disabling access time. Pretty self-explanatory there. Underneath install, we have wanted by, and then equals multi-user.target. So just make sure that your file looks exactly like mine, with the exception being the description, also what and where and type. You'll definitely want to make sure that you update those fields for whatever they should be for your system. Next, what we'll do is save the file. I'll hold Control and press O, and then press Enter, and then Control X to exit out. Now that we've created that mount file, we need to inform systemd that is there. We need systemd to rescan its unit files. And to cause that to happen, we can type sudo and then systemctl, and then daemon-reload, just like that. And now we'll start to see where the systemd commands that I gave you a refresher on earlier tie into mounts. Earlier I used this command right here, systemctl status ssh, and that just gave me the status of the SSH service. But we could also do that with mounts as well. So check this out, systemctl status, and then I called mine mnt-disk_2.mount. So just replace that with whatever the name of the file is for your mount point. I'll press enter. And we can see that we can check the status of a mount the exact same way that we check the status of a service. So at the top right here, we're checking the status of a service. Here, we're checking the status of a mount. Again, a mount is a type of unit and a service is a type of unit. Now there's some other information that we can glean from this particular output right here. Let me just go ahead and clear the screen and I'll bring this back. We can see that this particular mount is inactive dead. Now earlier when we stopped the SSH service, we also saw this verbiage right here. So in the case of a service, inactive dead means it's not running. In the case of a mount, inactive dead means it's not mounted. We also see that this particular mount is disabled. So not only is it not mounted, it's also disabled. So it's not going to mount when I start the system, and it's also not mounted right now. And another thing I want to show you, if I list the storage of /mnt, we have nothing. Now here I am identifying that I want this particular mount point to be mounted at /mnt/disk_2. Now I didn't create that directory. That's why when I ran this command right here, it returned nothing. We'll be starting that shortly, but one more thing I want to show you is df-h. It shows us all of our mounted file systems, as well as how much space is free on each. Notice that the new volume that we set up is also not listed here. And that makes sense because it's not mounted, it's not started, it's just a file that we created. But let's go ahead and start it up and see what happens. So what I'll do is type sudo systemctl and then start. And we don't have to type the full path to the file. We only need the name. So mnt-disk _2.mount. We're going to start it up. And that was quick. We didn't get any output, so let's see if it worked. We'll type ls-l/mnt and check it out. We have the disk2 folder right here. Again, I didn't create that. Systemd took care of that for us. Also, if I run df-h, just like that, we now have the new file system, the new storage volume listed here at the bottom. How cool is that? So let's check the status of that mount and see how it's changed. That'll help us check the status. Let's see what happens. Now in this case, it's active and mounted. We already knew that because we saw from the df output that it's mounted. So this is what it looks like when you actually have a mount point via systemd, mounted. It's active, it's mounted. Instead of running like a service shows, it shows mounted right here, but it's still disabled. So what's going to happen is if I reboot this computer, this will not be mounted because if it's disabled, it's not going to start it at boot time. And for some of you, that might be okay. Maybe you don't want it to be active all the time and you only want it to be active when you go to use it. But what I'll do is just go ahead and enable it. And to do that, we'll type sudo systemctl enable the name of the mount unit, just like that. And it's creating a symlink here, which essentially means that it should have enabled it for us. So let's check that out. Let's see. Check the status. And not only is it active and mounted, it's also enabled. So when I reboot this system, this particular mount point will be ready to go automatically. Sorry to interrupt my own video, but I wanted to let you guys know about something really cool that I created recently. I put together the Ultimate Linux Commands Cheat Sheet, a downloadable PDF that covers all the essential Linux commands, as well as some great bash aliases, hardening tips, and other nuggets that I've picked up over the years. For just a $3 donation, it's yours, and it makes a great reference for those of you that work with a terminal. And while you're there, check out my other products at the shop as well. There's all kinds of Linux-themed products there. For example, t-shirts like the Dark Side of the Terminal. There's a classic Debian swirl tee, and even a shirt to warn those around you that you're obsessed with Linux. Every purchase helps keep this channel going. There's a lot of cost involved with editing all the content for you guys, and it also helps justify the amount of caffeine that I go through while I edit these videos. As always, thank you guys so much for supporting Linux learning. I really appreciate it. Now, let's get back to the video. Of course, the opposite of that is to change this to disable. And that's going to disable the mount, basically return it the way that it was. And now we see that it's disabled. So now you're probably seeing why I gave you a refresher when it comes to systemd earlier in the video. We use the same commands, systemctl, start, enable. We could also use stop if we want to on-mount it. We could use all the typical commands when it comes to systemd to handle mounts as well. In fact, I'll just go ahead and stop it right now. And you'll notice that df-h no longer shows that file system here in the list. And as you can see, it's inactive, dead, so it's no longer mounted to our system. All right, so the next thing I want to show you is how to mount a network share the same way. We just saw how to set up a storage volume, which is pretty cool. But maybe you have a NAS, maybe TrueNAS, Open Media Vault, or something else like that. And maybe you've created a share that you want to mount via systemd. In my case, I have an NFS mount that I'm going to be using for this particular example. I'm not going to show you how to create an NFS share in this particular video. I've already done that in another video. So if you want to follow along with me and mount a network share, but you need to create one, then you could just go ahead and watch that video. I'll leave a card for that video right about here. And then you can return here and we'll continue along. But I already have a network share on my network that I plan on using to show you for this example. Now, before we create the mount file, there is a package that we need to install, at least here on Debian. We need NFS support installed to mount an NFS share. So in the case of Debian, what we'll do is type sudo apt install nfs-common. I'll press enter and then enter again to accept the default of Y. And that's all we needed for that. We should have NFS support here on this system. Just like before, the name of the mount unit is very important. There's a particular naming scheme that we want to obey or follow. So what we'll do is type systemd -escape -p and then -- suffix. And this is also a mount unit as well. Even though we're going to be mounting a network share, it's still a mount, whether it's a storage volume like a hard disk, physical disk, virtual disk, network share. Regardless of that, it's still a mount. So we're going to see what we need to name our mount file. And then what we do, just like last time, is decide on whatever path we want to mount our network share to. You could use whatever naming scheme you want. But what I'm going to do is type /mnt nfs_share, just like that, and I'll press enter. And it gives us a file name. So what we'll do is copy that. And then we'll type sudo nano /etc systemd system, and then we'll paste in the same name right here, and we'll press enter. And just like last time, just to save some time here, I'm going to paste in the contents of this particular file. And here it is. Now you'll notice that quite a bit of this is going to look the same as our previous example, but there are some noteworthy differences. First of all, we have description equals. We'll set that to whatever description we want. Maybe you'll be more creative than I was feeling when I created that particular name, but anyway. Underneath mount, we have what, where, and type, just like we had before, but they're set to something different. Underneath what equals, we have the path to the NFS share that we're trying to mount. So first, I have the fully qualified domain name of the server. You could use an IP address if you don't have DNS set up. That's totally fine. Colon, and then the path to the share that we're trying to mount. So mine is under /mnt /volume2/public. If you're using a network attached storage server, when you create a mount point there, it should give you the full path to the mount, but basically it should be pretty self-explanatory. Fully qualified domain name, colon, then the mount point. Underneath where, just like last time, we're going to mount this somewhere on our file system. And just like last time, I did not create that particular directory, but that is where I want to mount it. And systemd is going to take care of that for me, so it'd be a waste of my time to bother with creating that particular directory. Type is set to NFS this time around. Before, it was set to ext4, but in this case, it's set to NFS. We're going to use default options. We're going to have a timeout of 5 seconds. And then install, we have wanted by, and set that equal to multiuser.target. But anyway, here's the file. All you have to do is just change description, what, where, and type to match yours. Now, obviously, you can mount Samba file shares via this method as well, but I'm just keeping this tutorial very simple and just mounting an NFS share, so that's why I'm doing that. But anyway, I'll hold Control and press O to bring up the save dialog. I'll press enter to save the file, Control X to exit out. Just like before, I'm going to run sudo systemctl daemon reload. That lets systemd know that the file is there, that we created a new file. And now what we should be able to do is type systemctl and then status, then mount -nfs_share.mount, just like that. And we see the same output that we saw earlier when we used a storage volume. It's inactive, not mounted. That makes sense. I didn't even try to mount it yet. It's disabled. Again, doesn't come up during boot when it's disabled. And also, the folder for it has not been created yet. Anyway, what we'll do right now is type sudo systemctl and then start, and then the name of the unit file. In my case, mnt-nfs_share, and then .mount, just like that. We want to mount that particular share. And I'll press enter. Let's see what happens. So far, so good. So let's check /mnt. We want to find out if that directory was created, and it was. So far, so good. And df-h also shows that particular mount point down here at the bottom. I have 2.2 terabytes free on this share, and I'm mounting it here under /mnt/nfs_share. Check the status. And we see that it's mounted, it's disabled, And we could enable this if we wanted it to mount during boot, but I'll just leave it disabled. I think that's good enough. But we know that it's working. And also what I'll do right now is just unmount it. Just like that. And we see that it's not mounted. Anyway, I just showed you how to mount an NFS share via systemd, which is really cool. But what I want to do now is show you another type of unit, and this is called an auto mount unit. Auto mount units will basically mount the remote file system automatically. Now you might be wondering, why is this necessary? After all, you could simply enable the NFS mount that we created earlier and do, well, the same thing. However, the difference with auto mount is that the NFS share will only be mounted when you go to use it and will automatically unmount when it's not in use. So basically the difference between an auto mount and enabling a mount point is that it has more intelligence. And one reason why you might want to do this is because sometimes you might encounter file locking issues or other headaches when using NFS shares. So what we'll do is set up an auto mount unit that's going to make this a lot better. To start out, just like last time, we need to know what the name of the file should be. So type systemd escape -p, then -- suffix. And before we used mount for the suffix, but this time we're going to be creating an auto mount unit, so the suffix changes here. So that's what we want to create. Then we'll type the same path as earlier. It's important that it matches. And for mine, I used /mnt/nfs_share. So I'll press enter. And then we get the file name that systemd wants us to use for this particular directory. Just like last time, we'll type sudo nano/etc systemd and then system. Then we'll paste in the file name right here and press enter. And what I'll do is paste in the contents for this particular file. And there's actually fewer lines in this one than the last one. But anyway, taking it from the top, description equals, same idea here, where we want this right here to be set to the exact same path as the mount unit for our NFS share. Now we have timeout idle seconds right here, abbreviated SEC. We set that equal to 10. And what that means is that when the mount hasn't been used for more than 10 seconds, it's just going to unmount itself. Of course, you could change that to a higher number of seconds if you want to. And just like before, at the bottom right here, we have wanted by multi-user.target. So not as much going on here, but it does change things quite a bit. So I'll save the file, again, Control O and then Enter to save the file, Control X to exit out. And of course, we need to reload systemd, so sudo systemctl, and then daemon-reload, and it should be good. So what we'll do now is check the status. We just want to make sure we have no errors. Systemctl status, then mnt-nfs_share.automount this time. And we'll press enter. Now in this case, it's inactive and dead. So obviously it's not running and it's disabled. So now what I'm going to do is enable the auto mount. Now, right now, my network share is not mounted. And that's what we need right now. We don't need to worry about that. But what we're going to do is start and enable the auto mount unit. What I'll do is type sudo systemctl. I'm going to type enable because I wanted to start at boot time. But I'm also going to type -- now, just another trick I wanted to show you. If you use enable and then -- now, it'll enable and start the unit at the same time. So you don't have to run 2 commands to accomplish that. You could do it in one. Then we'll type the name of the unit. Just like that. We'll check the status again. It's active and it's waiting, which means that it's waiting on something. I'll explain. It's enabled. It's going to start at boot time. But here's what's interesting. It's not mounted. But I started the auto mount. Why isn't it mounted? That's interesting. Well, here's what we'll do. We'll cd into the directory where it's supposed to be mounted, which is this one right here. Okay, so the folder wasn't there. It let us go into the folder. So something must have happened. So what exactly happened? Well, it mounted it. So you'll notice the difference between simply enabling a mount and an auto mount right away. With an auto mount, the network share is not going to be mounted or used at all until you go to use it. I started and enabled the auto mount, but that still didn't mount the network share. You can see above that it wasn't present when I ran df-h, but then I went into the directory and then checked df-h again and it was mounted. So what happened is when I went into the directory by typing cd, then systemd saw that I was going to use this particular mount point, and then it mounted it automatically, and it did it so fast that the cd command worked and the df-h command worked. It was nearly instantaneous. So now what I'll do is just go out of this directory right here. In fact, I'll just go back to my home directory. I'm going to wait a few seconds. As you can see right now, it's mounted, and we had a timeout set of 10 seconds. So I'm going to let that pass, and we'll try this again. Now more than 10 seconds has passed at this point, so I'll run df-h, and you'll notice that it's not mounted. And that's exactly what an on-demand mount happens to be. It's mounted automatically when you go to use it, or even a program goes to use it. If anything goes to use that particular mount point, it's going to be mounted automatically. And when you go to reboot a server that has on-demand mounts, you have a less likely chance of a stuck mount or some craziness going on when it's on demand. It's just more efficient in general, and it's a great way to do it. Now, there's a few things I want to make sure you're aware of when you're using an auto mount. Okay, there's some important things to know here. So I'm going to go back to the beginning. So what I'm going to do is just check the status of the mount point itself. Which is this one right here. Now in this case, it's inactive dead and it's disabled. Now when you're using an auto mount, you should have the mount disabled, because at that point the auto mount is controlling whether or not it's mounted or not mounted. So you don't have to worry about starting it. You don't have to worry about enabling it. The mount only exists for the auto mount to turn on as it needs, but the mount itself doesn't need to be enabled, because again, the auto mount is taking care of that for us. Now here, I have enabled and it's active waiting. So now the auto mount is controlling everything. But anyway, in this video so far, I showed you how to mount additional storage volumes. I showed you how to mount an NFS share. And I also showed you an auto mount unit that's going to mount and unmount that share for us. So you should have everything you need to mount your file systems with systemd. And there you go. In this video, we did all kinds of things. I showed you how to mount file systems with systemd. I showed you how to mount secondary storage, either a physical volume or a virtual volume on the same host. And I also showed you how to mount an NFS share as well. And then at the end of the video, I showed you auto mount. Auto mount is a very cool feature when it comes to systemd, and I think you're going to have a lot of fun with it. Anyway, if you enjoyed this tutorial, if this helped you out, then be sure to click the like button to let YouTube know. In the meantime, I'm working on all kinds of really cool Linux-related shenanigans for you guys, so be sure to subscribe to Learn Linux TV for the latest in Linux, and I'll see you in the next video.